Alright, in the last video, we looked at 27 times 14 equals 378. And we looked at that by using the lattice method of multiplication. And I'm going to get a different color marker. Now I have black and blue. Not extravagant colors, but hey, they'll do. Because this time, we're actually going to say, okay, what is 2 7/10 times 14? And we're going to look at how those answers are different. And remember, when we were talking about multiplication of decimals, we really emphasized what the multiplication symbol, which is right there, what it actually meant. We said that it was of, right? And we said that this is 14 groups of 2 7/10, or 2 7/10 groups of 14. But I think it makes more sense when we say 14 groups of 2 7/10. Because that's what that's saying, right? We've already talked about that in math class. So you have some level of understanding of what I'm saying right there. If not, I'm going to have a really defined video of a really simple and defined video of multiplication of decimals. And I'll take time explaining every single aspect of what the multiplication of the decimal actually means. But for right now, we're just going to say, okay, we have some general understanding of multiplication. We have some general understanding of what decimals mean. And we're going to go into just crunching the numbers. If you remember, when I said multiplying decimals in the very beginning of the lectures, we're not going to focus on the decimal right now. We're just going to multiply it as if it were two whole numbers. And we explain that by explaining the properties of multiplication. We said that they were both commutative, both associative, and they both had the identity property as a component that they both shared. So decimals and whole numbers both have the same properties of multiplication. And we talked about that in class. I know there's 2 digits here and 2 digits here, so I need a 2 by 2 lattice. In the last video we talked about how to make the lattice. If it were a 3 digit by 2 digit, I would need an extra column here. If it were 4 by 2, an extra column here. If it were 3 by 3, I would need an extra column and an extra row. So you kind of see how we build the lattice, right? So I'm still going to plug in 27 times 14 here. Because like I said, we're not worrying about the decimal place. Okay? And then 1 times 7 is going to be 7. 1 times 2 is going to be 2. 4 down here times 7, the product is going to be 28. And 4 times 2, the product is going to be 8. Okay? Looks very similar to the last video. You're kind of like, hey, I just saw this, Mr. V. What are you doing? Well, give me a minute. I know that I need to add the diagonals, so now I'll get my other color out here. Ooh, he's using 2 colors. Look out. That is the sound of a dying marker right there. Poor Expo marker. He's done his job. Alright, so here's the blue diagonals, right? And that marker is... Oh, I missed the trash can. It is done. But we've been able to highlight our diagonals, so we're pretty good. We know that we dropped the 8 down because that's added to nothing. Don't worry about these over here. We've already used those guys. Those were the multiplication sentences. Now we know we have 7, 2, and 8. I get add 7 and 2 and then add 8. But I know 8 plus 2 is 10. Plus 7 is 17, which really makes it easy. I carry the 1 to the next diagonal, which is this guy right here. Right? I know that 0 plus 1 is 1 and 1 plus 2 is 3. Don't got to worry about the other 0. So I have the 3 right here, and this 0 right here. He doesn't even matter. He's just up there chilling. I rewrite this as it is in the diagonals. Okay, I rewrite it up here. It's 3, then 7, then 8. Okay? You're like, whoa, Mr. B. 2 and 7/10 times 14 is not the same as that. We just did that. Well, if you remember, I said, however many times, however many places after the decimal place, right here, there are in the multiplication sentence. So if there are 1, if there are 2, if there are 3, however many there are, you count them up. So I have a decimal place here, and then I have 1 to the right of it. Do I have a decimal place in this number? You would say no, and that would be correct. So I have 1 decimal place move, and I even taught you how to circle those. So how many circles do you have up there? Well, you have 1. In the number 378, we know that's a whole number. And then right over here, naturally, there's a decimal that we don't write just because it doesn't make sense. We don't need to write it. We know that it's there. But if I'm multiplying it by a decimal, I know that I need to move it to the left, okay? Because that would take place right here. And I'll show you why that makes sense. Okay? I'm going to erase this. I'll show you why that makes sense. Because I think we always need to make sense of our answers. If I had 2 and 7/10 times 14, okay? 2 and 7/10 rounds to 3, and 14 stays the same. So I'm basically saying this is about 3 times 14. Well, 3 times 14, 3 times 4 is 12, and 3 times 10 is 30, plus 1 is 40, right? Most people say 3 times 1 is 4 plus, 3 times 1 is 3 plus 1 is 4, but we know that is 3 times 10 because that's a 1 in the 10th place. So that's why I said 3 times 10 is 30 plus 1/10 is 40. So we have an answer here of 42 by rounding it. Our smart estimate, right? Yeah. I wrote that very fast and it looks messy. But anyways, that's our smart estimate. So is our smart estimate close to our actual answer? I would say that 37 8/10 is close to 42. So I would say that we were correct in multiplying that decimal. So we know that multiplication works with both whole numbers and decimals. The lattice method works with both whole numbers and decimals. The only thing that changes is when you get to your answer, you have to consider, okay, how many decimal places did I have to the right of the decimal? Well, I had 1 in here, so I had to move my decimal over to the left 1. In division, when we get to the division videos of decimals, the decimals do matter, and they do hold a lot of importance while we're doing our algorithm. But right now, just the way multiplication works it's just cool like that. I really like multiplication. I think it's easy whenever you look at it like this. But I'll post a video on there of the old school method and teach you all that as well, because hey, if that's the way that it works for you, do it. If this works for you, do it. It's all about how you feel comfortable solving it and how you get correct answers. All right? So feel empowered. Know that I support you 100% whatever way you choose. I love you guys dearly. I'm so proud of your hard work that you're putting into this. And hopefully we don't have any snow tomorrow and we can come in here and we can learn some more together. All right? Have a good evening, and I hope this helps out.